Now, the problem I have with finding data sets is finding a data set that has interesting properties and is relevant for your particular field. You are completely BMS students, so this is not a great data set for you. It is better for the nutrition students than anyone else, but it illustrates all of the important aspects of when you deal with a new data set. So we just had a look at that college student, female college student data set, and we had to work out what some of the columns meant because it wasn't clear from their labels. Now here the columns are well labeled, at least. So you've got the name of the cereal, the manufacturer, the type, the calories, the protein content, the fat, the sodium content, the fiber content, complex carbohydrate content, sugars, and potassium. Nicely labeled on the headings. You could do better and have units in it, which would be nice to see in these labels. So what does number 4 mean for protein? You presume grams per serving. It could be grams per 100 grams. You've got no idea what it actually means, but anyway, let's skip that. It's not as specific as it could be. They're all relative to each other, so it doesn't really matter, so long as you've consistently used the same things. You've got fat, sodium, fiber. So this data could be collected from by two different ways. One, you go out and buy loads of cereals, read the things off the side of the packet and put it in the table. Or two, you go and buy loads of cereals, you give them to an analytical lab that then does the experiment that allows you to figure out the calories, does the experiment that allows you to figure out the amount of protein and fat and sodium and fiber and complex carbs and sugars and potassium. You can do it either way. This is going to be from a few years ago, and also from the US. You can tell it's from the US because there's loads of types of cereals that I've never heard of in my life, like Apple Jacks and grape nuts, and what on earth is Maypo? Problem is that sounds like mayonnaise. It definitely doesn't sound like something I want to eat as breakfast. Wheaties Honey Gold, whatever. You've got all those different things. Now, I used to give this as the assessment data file. So when you were doing confidence intervals or any kind of summary statistics, this was the file I'd give you. And I say, tell me the average, the mean protein content of Kellogg's cereals. And someone would say, but Kellogg's isn't there. And I go, it is. And he says, no, the student would insist that I got it wrong. And I'd say, I'm pretty sure I haven't, because I've been using this for 6 years and I'm dead sure that every other year's managed to work this out and that the data's there. So when I say Kellogg's, what do you immediately think? What is Kellogg's an example of? So it's an example of a manufacturer, not a cereal. Exactly. Have you got a column that says manufacturer? Yes. Does it have Kellogg's in it? Doesn't say anything explicitly as Kellogg's. So this, and K exactly. So this was the problem that some people were coming to me and saying, you've done your data set for your rat appetite and dose wrong. You've got numbers 1, 2, 3, and 4, but the dose should be 0.0, 0.5, 1, and 2. Why is there a difference? Well, it's because one of them is the label for the data, and one of them is the actual content within the data file itself. So within the data file, instead of writing Kellogg's every time I see a Kellogg's thing, I put K. Now really you should put a number. That's even more efficient, but we'll not go that way. So what you're seeing here is the raw data as exists in the file. But if you go to view and value labels and put on the labels from it, now you can see what each of those symbols actually means. So K is for Kellogg's, N is for Nabisco, Q is for Quaker, R is for Ralston Purina, which I'm absolutely sure make cat food more than they make cereals. But maybe I'm getting, yeah, Purina definitely is a cat food manufacturer. General Mills. Now, I can tell this is an old data set because if you open your cupboard and get some cereal out of your cupboard, some of these manufacturers you won't see anymore, particularly Nabisco and probably General Mills as well, because they've been rolled into a company which was called Cereal Partners, and that is part of Nestle, because practically all of the food you have is produced by 6 companies. So Kraft, which is Kraft, Jacobs, Suchard, Cadbury, all of that, except they split their confectionery half off, and there's a company called Mondelez, which you don't realize it's called Mondelez, but it's called Mondelez. So all of the Cadbury's and research and Kraft research places in the UK, food research, are now called Mondelez Research. There's Nestle, there's PepsiCo, there's Coca-Cola, there's Danone, and there's one more that I can't remember. Anyway, practically everything, when you go to the supermarket and you go, oh, I prefer that brand over that, most of the time they're all made by the same person. So if you go, oh, I love Green and Blacks, it's so much superior to Cadbury, it is Cadbury's. And you go, oh, I like Milk, yeah, it's still Kraft. Doesn't matter, they're all owned by the same people. So you can argue about anything you like in terms of food, but practically it's all coming from 6 different factories. And you say, that's far superior if I get the Heinz. No, it's still, oh, Heinz is the other one. Anyway, next thing was cold and hot. Now, to be quite honest, this is a pretty boring and redundant data column, because there's a few things you have to eat hot, which are your kind of porridges, but most cereals you have cold. I know some people who have their cereals with orange juice. That's just strange. Instead of milk. It's wrong. Next, we have calories. Now, when you're looking at data, you want to look and think, well, do all those numbers seem kind of reasonable? 70 calories, fine. Yeah, 50, you'd expect low calorie. It's bran, all bran with extra bran. Like, how do you get more bran in bran flakes than it being 100% bran already? I can't imagine. That's with probably extra fiber. Just no, it's wrong. Then you've got things with higher calories, like Basic 4, whatever that is, and Almond Delight, things with nuts. They seem reasonable. All the numbers in there seem reasonable. There's nothing there that sticks its ugly head up and says, this is not a possible number. Go to protein, 4, some goes up to 6, down to 1. All the numbers are fine. There's no zeros, are there? No. Then you get to fat. You got a 1, a 5, a 1, and you got a 0. Now, do I think that zeros a possibility? I think yes, because cereal manufacturers are going to make low or 0 fat cereals. So zeros are possible. There's quite a lot of zeros. I'm not absolutely I was looking at Count Chocula and thinking, if that's got 0 fat, then I'm beginning to think that's a bit dodgy. Corn Pops, why would they have fat? It's almost solidly carbohydrate. Frosted Wheats. Right, so we're happy about the numbers there. Next we have sodium, and you see this is a much bigger number than these ones. So these are likely in grams, and these are likely in milligrams. 130, fine. 15, is that reasonable? And that one's 130 on 260. Could I get it down to 15? Yes, that's sort of reasonable. You'd have reduced salt. You would have some suspicion that there is some natural salt. Most biological systems have to have some salt in it, otherwise you end up with an osmotic problem. But seeds, I suppose, because they're the way they're produced, they might not have so much salt until they actually. I'm surprised they don't have any, because cells need to have a certain ionic strength. Anyway, go down to Frosted Wheats and it says it's got none. I'm not convinced by that. It's possible, but that's one of the cereals that I would not have expected to be low, so low salt that it's practically zero, that it's 0. I'm suspicious, and I'm perhaps suspicious of Mapo. But there's quite a lot down here that I'm less suspicious of. So puffed rice, it's just rice. If you taste rice on its own, it's the least tasting thing on the planet. So I can quite imagine that that has no salt in it. And the same with puffed wheat. Strawberry fruit wheats have got low salt. So the zeros, I'm a bit suspicious, but I'm not hugely. Go to fibre. You've got some things with lots of fibre which have lots of bran. 100% natural. How does this happen? One has loads and the next one has not a lot. All brands have got loads. All bran with extra bran, that's definitely got loads. And you've got lots of things that have no fibre in it at all. So Captain Crunch and Cocoa Puffs, there's no fibre in these things. They're just carbs. Look down, the numbers, they're not horrible. That's all good. Go down to complex carbohydrates. So you'd expect the ones that have zeros to have lots of complex carbs. That's good. The ones that have lots more fibre to not be so big on carbs. That's fine. Everything's good. Going down, 18. This one's got 21. 20. -1. Wow, that's a bit that sticks out. This would be the ultimate diet cereal. You eat it, it consumes complex carbohydrates from your body. That would actually be bad news. You prefer it to be fat consuming rather than complex carbs consuming, because your brain's going to be going, give me carbs. Your brain's quite keen on sugars. Keeps it going. So this is definitely a missing value. So one thing you want to do is check in the variable view, is there a missing value marked for complex carbs? No, there isn't. Now that would be a problem, because if you calculated the average without having the missing value in it, it would be calculated using that -1, which is most definitely wrong. That -1 is also in sugars, so we can put that in sugars as well. Now, how did this arise? Now, I don't think this suggests that this data set was not collected by people looking at the side of the packet. It suggests that it was sent to a lab and people worked out the amount of complex carbohydrates and sugars. And what happened is, when they did the experiment and ran the machine doing the analyzer to do this, it stopped working, or they didn't record it properly, or something happened. There's some reason that these two matched experimental details disappeared. That often happens. Now, if you've got a really big, complicated data set like this, do you want to cut out that entire line just because you're missing these two values? Well, if your question is about all these other things, like which cereals have the most protein in them, then you don't really care. And to be quite honest, collecting massive amounts of data like this across loads of different variables is interesting for summarizing the data, but it's not fantastic for asking a single scientific question. But that's fine, so we've marked that as missing. Now if we go to potassium, again there's another -1. In fact, there's two -1s here. So it could be that they don't record that potassium on the side of the packet, but I would think that if that happened, every cereal manufacturer wouldn't record it on the side of the packet. And one's from Ralston Purina and one's from Nabisco, so it doesn't make any sense. Either that or your machine failed twice for that particular analysis, which is possible. So therefore, the potassium analysis is more susceptible to going wrong than any other. It's twice as likely. And it seems very reasonable that the carbohydrate ones both went wrong together, because they're going to be part of the same analysis process. If you can remember going back to how you analyze starches and carbohydrates and things, and how you test for protein. Right. So that's the data set. It's now sorted out and clean. So I now know that the data's fine.